students, welcome back to Rasayan. In this video I am going to explain about resonance energy. What's the difference between resonance and mesomeric effect, and also resonating structures of some compounds. So first we will do resonance energy. The resonance hybrid of an entity is a more stable structure than any one of the contributing resonating structures or canonical structures. Now see, what is resonance energy? Resonance energy is the difference in energy between the actual structure of the entity and the more stable contributing resonating structure of a particular compound. Now how to calculate resonance energy? There are many methods to calculate resonance energy. One of the methods is observed heat of hydrogenation minus calculated heat of hydrogenation of the stablest resonating structure of the hybrid. As for example for benzene, so this is resonance hybrid of benzene. Its observed heat of hydrogenation value is this one, and this is hypothetical molecule means stablest resonance hybrid calculus structure of benzene. One of the resonating structure of benzene, it is having heat of hydrogenation value 360. So this difference means 152 kilojoule per mole is resonance energy of benzene. We have studied in the last video about contributing resonating structures, how to write contributing resonating structures. So you have to remember one point: the more the number of contributing resonating structures, more is the stability of the species. If one species is having 4 contributing resonating structures, another is having 3 contributing resonating structures, first one will be more stable one. Our next topic is resonance effect or mesomeric effect. So what's the difference between resonance effect and mesomeric effect? Both are almost similar. Resonance involves displacement or movement of electrons in conjugated system, and due to resonance there is generation of positive and negative charge, that is polarity, in the molecule. Consider this molecule. (1,3-butadiene). Here pi bond is there, here pi bond is there, so here pi conjugation is there. So resonance is taking place, but there is no influence of external group. So resonance means no influence of external group. In benzene also pure pi conjugation is there, means resonance effect is there. But if your compound is like that, in benzene ring one OH group is there or NH2 group is there, Cl atom is there, what will happen? Resonance takes place with influence of external group. Here also, if we are having this structure CH2 double bond CH, then CH double bond CH OH. So if the system is like that, double bond, double bond, single bond, lone pair, then conjugation will take place, and here it is called mesomeric effect. Here also lone pair is there. I am showing only one lone pair. Double bond, single bond, lone pair, double bond, single bond, lone pair, double bond, single bond, lone pair. So here it is called mesomeric effect. So if you want to define mesomeric effect, it is denoted by M. Resonance takes place with influence of external group or atom is called mesomeric effect. Now see here, first you have to check conjugation. If in the molecule conjugation is there, as I told you, so here resonance is possible, and since external group is also there, it is called mesomeric effect. So this will be shifted here, this will be shifted here, and then it will be shifted here. So what is the next resonating structure? double bond is shifted here. So this is mesomeric effect. These are the resonating structures. Now see, mesomeric effects are of two types. One is plus M, another is minus M. What is plus M effect? A group is said to have plus M effect when movement of electrons is away from an atom or group attached to the conjugated system. So here movement of electron is away from the group towards the pi conjugated system. So it is away from the group, then it is called plus M effect. This is phenol with benzene ring, one OH group is attached, directly attached. It is having lone pair, so double bond, single bond, lone pair, all are in conjugation. Resonance will take place. And since resonance is influenced by external group, it is called mesomeric effect. Now what will happen here? This pi bond will clip. It will supply electron density here. So we have to write the next resonating structure like this way. Other resonating structures are also there. We will do all those later. Here movement of electrons is away from this group. So here it is called plus M effect. Here movement of electrons is towards benzene ring. Therefore, we can say this one as plus M effect. Now see how we will understand which atom or which groups are having plus M effect. Now see, with this conjugated system, which atom is directly attached, it is called key atom. Here key atom is oxygen because this oxygen is directly attached with the conjugated system. So key atom is oxygen. For this molecule, aniline, key atom is nitrogen. So if key atom have lone pair of electrons or negative charge, then it shows plus M effect. Once again, the key atom means the atom directly attached with the conjugated system should have lone pair of electrons as it is here, or negative charge means this one, phenoxide ion. If key atom is having lone pair of electrons or negative charge, it will show plus M effect. Some atoms or groups showing plus M effects are all those. Now minus M effect. Suppose with the conjugated system, one group is attached such that movement of electrons is towards the group. Then we can say the group is having minus M effect. A group is said to have minus M effect when the movement of electrons is towards the group. In plus M, it is away from the group towards the conjugated system, and it is away from the conjugated system towards the group. Now which groups are having minus I effect? CH2 plus, NR3 plus, nitro, cyano, aldehyde, COR, keto, carboxylic acid, ester. All those groups are having minus M effect. How will you identify? If key atom has vacant orbital or pi bond. Now see here, if with conjugated system, this is attached. This is benzylic carbocation. So key atom is this one, which is directly attached with the conjugated system. So it is having vacant orbital. Or think about this one, benzaldehyde. Here key atom is this one, which is directly attached with the conjugated system. Key atom is having pi bond. Here key atom is having vacant orbital. So all those are having minus M effect. Now we will draw resonating structures of some compounds. First one is phenol. We will draw resonating structures of phenol. This is phenol. Now see here, double bond, single bond, lone pair, all those are in conjugation. Here also conjugation is present. So what we have to do? We have to shift this pi bond. It will be shifted here. So next resonating structure. Here negative charge. Negative charge means one lone pair also you can show. Here double bond OH plus this, here dot minus, here double bond, here as it is this part. Next structure, everywhere double headed arrow, between two structures double headed arrow. Shift this one, shift this here, the pi bond, okay, we are shifting. So next structure, so since pi electron density is shifted here, we are getting back lone pair. Now you see here double bonds are at this position and here double bonds are this position. So these are all resonating structures, 5 resonating structures. As I told you earlier, OH group is having plus M effect. It is having plus M effect. Means electron density is shifted towards the ring. It is away from the group towards the conjugated system. It is having, OH group is having plus M effect. And when you are observing resonating structure, you can see with respect to OH at ortho position and para position, there is negative charge. So for plus M effect, ring will get negative charge at ortho and para positions. So if electrophile will attack in the ring, it will attack at ortho and para position. Electrophile means maybe Br plus, halogenation, nitration, NO2 plus, all those are electrophiles. So these will attack at ortho and para positions here. Now students, remember groups having plus M effect means all those groups which direct electrophiles at ortho and para positions are called ortho-para directing groups. Why these are ortho-para directing groups? Why electrophiles attack at ortho and para position? Because all those positions electron density is increased. These groups increase electron density of benzene ring, so these are called activating groups. We have seen during drawing the resonating structures of phenol, we have seen already how these groups are increasing electron density at ortho and para position of benzene ring. So these groups are called activating groups. Now see, this is aniline. In H2 group, it is having also plus M effect. So like phenol, we can draw here resonating structures. So this is your home task. Now see, this is benzaldehyde. Here conjugation is there. And also you can see double bond, single bond, double bond. So here conjugation is there. So resonance is possible, and we have seen already CHO group is having minus M effect. Minus M effect. Since it is withdrawing electron density from benzene ring towards this group. Clear how to draw resonating structures. Oxygen is more electronegative. So this bond will break, pi bond will break. like this. This carbon will become electron deficient, so pi bond will slip in this direction. Next structure. This part as it is, here double bond will be transferred here. Okay, so here double bond, carbon, O minus. I am not showing here lone pairs. You can show, or you can show like this. Here hydrogen. Here one positive charge. After that what will happen? Next structure. So here double bond will be transferred. Here one positive charge. Here as it is. Then here double bond. This. Now here I am writing. After that what will happen? This pi electron density will be transferred here. So this electron density will be transferred here. We will get so here 5 resonating structures we are getting. What is the difference between this and this structure? See, here double bonds are at these positions, here double bonds are at these positions. So total 5 resonating structures we are getting. During writing the resonating structures, you can see that with respect to CHO group, this is ortho position, this is para, this is ortho. So ortho para positions are electron deficient. That's why positive charge is coming. If electrophile will attack here at this compound, what will happen? Where electron density is more, at that position electrophile will attack. We have seen at ortho and para position electron density, ortho and para positions are electron deficient. So obviously electrophile will attack at meta position. It is comparatively more electron rich, electron dense. Now you note down, because of minus M effect of CHO group, electron density at ortho and para position is less but more at meta position. Because see, when you are writing resonating structures at meta position, positive charge is not coming. That means this meta position is comparatively more electron dense. So electrophile will attack at meta position. Those groups like CHO, NO2 also, those are having minus M effect. Okay, those groups decrease electron density in benzene ring. That's why plus charge is coming in the ring. These are called deactivating groups. So is it clear, activating groups and deactivating groups? Now see, halogens, if it is attached with conjugated system, halogen, you know, it is having plus M effect, and due to plus M effect it is ortho-para directing. But this is also having minus I effect. That's why it is deactivating group. It is abstracting electron density from benzene ring. So it is deactivating group. And between plus M and minus I, this is dominating. Minus I effect is dominating. That's why halogens are orthopara directing, but it is deactivating group. And this is very important. You note down, mesomeric effect at meta position is 0.